Well, hello everyone, and welcome back to Adrian's Digital Basement. This is part 2 in the TRS-80 Model 1 repair, and the machine is strewn across the bench here because I haven't worked on it at all since the end of the last video. Where I left off on that video, and I recommend you might want to watch it before watching this one because this is a continuation, but where I left off, there were 3 faults with this machine still, and I was hoping to get this all fixed up in one video. Well, it turned out that that wasn't going to be the case, and to be honest, I'm recording this now. I hope that I get this machine fixed by the end of this video. So, without further ado, let's get right to it. All right, here's the Model 1 completely splayed out on the desk. I had been working on this machine for a good number of hours and I was kind of getting a little bit frustrated. So I decided to just call it an evening and I went and watched a bunch of Netflix upstairs. So where we left off, there were all sorts of problems with this one, as I mentioned in the intro. But what I want to focus on right now is this weird voltage regulator problem that's going on with the 5-volt rail. Up here on the screen is that circuit right there, and there is this large package transistor, which is the underside of the board right here, and it has that heatsink on it, and that is what is supposed to actually be doing the voltage regulation. And then this here says reg drive Q3, that was the little small transistor. It's not tiny, but it's a smaller package that was getting burning hot. The thing is, when I look at this design, and I don't fully understand it, so I have to admit I ran this by Frank, IZ8DWF, who's a total wizard at this sort of analog transistor stuff compared to me. I asked him if it was possible if the Q3 transistor, the small one that's getting really hot, could actually do all the regulation of the 5-volt rail if something was wrong with the larger transistor, and he actually thought that that was possible, although it would be dropping all the current through this resistor here unless this large transistor was shorted between the emitter and the base. This is the collector over here on this side, this is the emitter, and that is the base. If the large transistor were shorted between emitter and base, then it would give unregulated voltage right through here, and then this transistor could be regulating all the current. Now there's a whole feedback circuit with this IC here, which is doing the 5-volt regulation. So that would be out of the normal design of this circuit, but it is possible. If this transistor weren't shorted, he doesn't think it would necessarily be possible because this 68 ohm 1 watt resistor, which incidentally, you can't see it, but it's all on the other side of this board. I did go ahead and I checked all those passive components with my multimeter and they all appear to be good, including that resistor. If the large Q4 transistor here were just dead, say it didn't work at all and it wasn't shorted, then if this smaller Q3 was going to try to regulate the 5-volt, it would have to do it all through this 68 ohm resistor, which he doesn't think is really possible unless the input voltage is unusually high. But looking at the schematic, C9, a 10,000 microfarad cap, is only rated for 16 volts. So it's very unlikely that that input voltage coming into this little voltage regulator is more than, say, 12 or 10 or 11 volts. So, because that voltage is somewhat low, he doesn't think the 68 ohm resistor is actually going to be enough to make this computer work. Okay, so let's take a look at some of these components. So right here is the large package, which is Q4 on the schematic. I marked this with a C here for the collector, that these 2 screws are right there. This is the emitter right here, and this is the base. Now, he thought that between base and emitter was actually shorted, and I have the this on diode check. Now, when I touch this, we get a possible short, but the thing is, remember on the schematic here, we have a 68 ohm resistor that actually is going between the emitter and the base. So I'll need to lift that resistor to know for sure if there's actually a short. So let me do that. Now I know we're looking at the back side of the board, and that's just because it's such a pain to flip this thing over with the stupid keyboard attached. But I can tell right here that this is the resistor here, which on the schematic is labeled R1. Okay, it is now lifted. So let's see, get the probes. Let's check between the base and the emitter now. No No apparent short. We should see diode drop one of the directions. And there it is, 0.54 volts. So that seems normal. Now the other thing to check is between the base and the collector. And I'm actually going to go right to the package on the chip itself. And there you go. You can see on the multimeter, it's kind of jumping around a little bit. I don't think I've got, there we go. 0.53, so that's normal as well. Question is, let's go over here to this here, which should be coming through that screw. Okay, yeah, we are getting the correct drop there as well. So that seems okay, but this screw is loose right here. I might need to tighten this up a little bit, and it has a bit of corrosion on it. I think what I want to do is try to use my transistor tester here on that thing. I know it's in circuit, but let's just see what happens, especially now that I lifted that resistor. I'm gonna have to do a little finger gymnastics here to kind of hold everything on while I test this. Come on. All right, let's try again. Unknown part or damaged. What? And it has a picture of a diode? You know, because it really feels like that part is misbehaving, I'm just gonna remove it from the board. I don't think it's gonna be too difficult. Plus it will give me an opportunity to check for good continuity with these screws here. All right, there's the part there, Motorola 2N6594 from 1978. Now we should be able to test this thing with my little tester. Where is it? Here it is. I do need to buy a better one of these. This thing is a piece of junk. But it should do the trick. It usually does test things. All right. All right, yeah, there we go. It is testing normally. PNP transistor. Yeah, BCE. Okay, so, I mean, nothing does seem wrong here with this part. I love how there's like a pitiful amount of thermal compound on there. I wonder if I should attempt to add more. I just happen to have some of this Noctua stuff here. Let's just use a tiny little dab of this. Luckily with these parts, the pins are offset from the screw holes, so you can't really put it in backwards. All right, before I reattach these two pins and that resistor, let's just check this other transistor, the one that's getting really hot. Okay, so that looks normal. And that looks normal. So with diode check at least, that does seem fine. I mean, I think I pretty much knew that that transistor was working, because if it was shorted, then that would have potentially been sending like 10 volts into this entire computer. The whole design I don't like of the regulator on here. It's weird that both those transistors are connected to the unregulated and the regulated supply, even though there is that resistor. I don't know, the whole thing is just a bit so strange to me. I also don't think there's any kind of fuse on this thing. Okay, everything is soldered back together, but I just had a thought, like, I don't know if I trust that these screws here are actually passing the current properly, because they absolutely have to. Otherwise, it basically is gonna act as if it's open. And the reason why I see that is, look, it's not in the best of shape. I mean, there is definitely silver there, and the other nut that's on the bottom has a little, I don't know, sharp edges there, so that should dig into the case. But I just don't know, the fact that it's so oxidized, this is actually passing current for the regulated supply. So if it's not working, well, that's gonna be a problem. Let me see if I can find another nut and washer. All right, I found a new screw, so it's shiny, along with a new nut, and that is installed. So hopefully that's gonna make sure there's good continuity from the case of the transistor through to the trace on the back of the board. Alrighty, so looking back at the schematics here, I actually notice here there's a Zener diode here, CR1. I have a feeling that that is like a 5.1 volt Zener. So if the voltage rail does go too high, like if those transistors shorted, then that diode would be taking the brunt of all that extra current, and it would end up short circuiting, which should protect the rest of the ICs on this board from any possible harm. Now it'd be nice if there was an inline fuse somewhere on this trace here, because if that diode were to short circuit, then it would blow that fuse and help protect the rest of the chips on here. Now one thing I'm looking at is there's definitely been rework right here on this IC. And when I flip the board over, it is the IC Z1. And Z1 is the actual voltage regulator IC. Now I'm wondering if this IC was replaced. Well, it's obviously been replaced. And I'm wondering if whatever they put in place here, which is a UA723CN from TI, I'm wondering if that is not a drop-in replacement for the Motorola 1723CP. It has a very similar part number, but I'm wondering if when that failed or why it was changed out, what if that damaged some other component on here? All right, well, I think what I need to do is let's try to power this computer up, flipped over like this. And let me use the multimeter to A, make sure that we're getting a solid 5 volts, but then I can probably check for voltage drop on some of these transistors just to see exactly where the current is being dissipated, because it should be dissipated into that large package, the one I took off and put back on, versus the small one. Okay, so the way this works is the unregulated voltage comes along here, it goes into the emitter, and what comes out of the collector, and then through this large resistor, which is a 0.33 ohm resistor. This right here should be the 5 volts. So let me turn this on and see what we got. Okay, we're getting 4.85. Let's see what kind of voltage drop we have here between the emitter and the collector. We're getting 5.4 volts. How about across this resistor here? We're getting 0.73. Let's see if the small resistor is still getting hot. It is not. And is the large package getting warm? It is. I wonder if I fix that. Oops, that's wrong. I should go to here. Yeah, it's dropping 5.4 volts. And then looking here at the emitter going into the large package, we're getting 10.5 volts. So that's what the unregulated DC voltage is before it gets dropped down to what we get on this side of the resistor here, 4.85. Now that is slightly on the low side. There are 2 potentiometers right here. You can't see them, but they're on this side of the board that control the different voltage rails. I think 12 volts and 5 volts. And here's the 5 volt adjustment here. It is called R5, which is this one right here. I think this one would be for 12 volts. So what I want to do is I want to try cleaning these potentiometers, but I am going to check the resistance first so I can adjust them and then set them back to what they are. Okay, 0.68 kilo ohms or 680 ohms. So I'm going to get the old QD cleaner here. I'm going to spray this. And I'm going to run this through back and forth just to get it a little cleaner. And then I'm going to set it back to 6.8 on here. 6.1, because I don't know which way goes higher or lower. Okay, the other way. 7, 8, 7, 2. Just trying to get this back to 6.8. Okay, close enough. We're at 7.70. All right, so multimeter is set for voltage. Let's turn this on. Okay, we're getting 4.80. Let's see about adjusting this. That's the wrong direction. Up, 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 up. Come on. Let's get to 5 volts. Okay, there we go, 5.01. That is close enough. Now, do I think that this particular problem with the regulation has anything to do with the sync problem or the video signal problem? No, I don't think so, not at all. But I was very concerned how that small transistor was getting incredibly hot, like burning your finger hot, and that the large package was cold to the touch. So I really don't think that that large one was actually doing anything, which means that who knows what instability was going on with the circuitry on this thing. So maybe it's somehow related, maybe. Okay, so this thing is flipped back over. Let's turn the power on. And when I look at the voltage here, 5.01 is exactly where I left it. Let's just see if that is indeed what the chips are getting as well. There we go, 5.00 through the traces and whatever. And then let's check what's getting hot here. Oh yeah, that package is getting quite warm now. This one, nothing. Nothing at all. I know I didn't do thorough testing in the last video, but I could tell you that this small transistor was burning hot after just a short while, and that this package here, even after 10, 20, 30 minutes of running, I touched the package and the heatsink, and it wasn't even warm. And now it's totally, totally warm which is exactly what I would expect from this design. So the only thing I can think of is that that screw and that nut had a bad actual connection, and maybe with my multimeter, it was fine. It was testing fine, just like on the Model 3 with that ribbon cable. When there was no load, or only the load of the multimeter, which is almost nothing, basically it was perfect. But as soon as actual current tried to flow through that screw, because it is the collector and that is the output of this transistor for the 5 volts going to the board, suddenly it wasn't able to supply all the current, and that little guy was having to pick up all the slack. Now, it's kind of a weird design that wouldn't even work that way, that the whole thing wouldn't just fail. But yeah, oh, yeah, that is warm. That is very warm. And the little guy here, it's not even warm at all. All right, so top tip on the TRS-80 Model 1, check the screws on the case for that large transistor and make sure that they are not oxidized like the ones that were on here. And if they are, swap it out or use a wire wheel or whatever, polish that and put that back on, and maybe a little Deoxit to keep it from corroding in the future, because if you use a wire wheel, it will just oxidize again. Oh yeah, that's a toasty boy there. Ooh, that's warm. So yeah, okay, good. That is functioning normally. It's designed to get warm. I can't believe so much current was flowing through that small transistor. It might be within my best interest to just replace that transistor, but I'm gonna leave that for now. And yeah, I don't know. I need to try to remember in the future. Maybe I'll leave myself a note inside the case to say, regulation problems, suspect, what is it, Q3 might need to be replaced. All right, let's go back to the video problems and that sync issue. So in the last video, we found that the horizontal drive signal came in through pin 13 here on Z6, and it's made its way through this pot here, and it kind of loops around down to here. We saw it coming into pin 9 here on Z6, and then it didn't come out of pin 8. It was just, the signal was just high. Now I cut that pin, it is one of these chips over here, I cut that pin, and all of a sudden that signal came back. It was there on pin 8. I suspect that it's actually Z5 that is the problem. Now, I chit-chatted with Frank a little bit about this whole weird sync combiner circuit, and he says that these chips here, which are 74C00 and a 74C04, are really weird CMOS variants of the 74LS logic chips that basically suck. They fail a lot, they were very unreliable, and they were only really used for a certain time period back in the old days. And if you might be familiar with like the 4000 series of chips, like the 4011 and the 4061 and 4069, stuff like that, those chips are pretty functionally the same as the 74C series. But the really annoying thing is the 74C04, the equivalent 4000 series is like a 4000, I think it's a 69 maybe, same pinout. You can just swap the two chips. But the 74C00 is not pin compatible with the 4011, which is a functionally the same chip. It's just some of the gates are swapped around. So I don't have any 74C chips. I would just replace these two possibly problematic chips if I had these in stock, but I don't. So all I can really do is, well, try to figure out which of these two chips it is, but I can't really because I don't have any spare chips, and substitute in a 4000 series part. Now, again, the issue is, if I'm going to try to substitute in a 4811 for the 74C00, I'm going to have to build a little socket adapter and swap some of the pins around, which I really don't like the sound of, but I don't think there's much I can do. So I guess I need to do is let this machine run now that I fixed this voltage regulation problem, and let's see if that has any effect on the video circuitry at all. I'm just going to turn this on here, and there it is. We have a good video signal, and the diagnostic ROM is installed, so we're just going to be seeing it running through its particular diagnostic tests. And I mean, it's good to know that it's working, but I think what I need to do is just pull the diagnostic ROM out, put the ribbon cable back in, and let's put it back in the bottom case. It never seemed to have any issues with the motherboard flipped over like this, and maybe it is a heat issue with some other chip. I don't know what's going on, but clearly when the board is turned over this direction, any heat that is coming off the parts and stuff can just go upwards. but inside the case, the keyboard on top of it's upside down and the heat's gonna build up more on it. So let's replicate the original configuration that causes it to fail. All right, the computer is back in the case. The video cable is connected. Let's turn this on. Do we have a video signal? And we do have a video signal, but it's really weirdly flickery. So you might notice, this is what I was talking about, how in BASIC, the characters are gibberish, but okay, let me try to fix this flickering problem first. Okay, I think I fixed the flickering problem. I just had to adjust the vertical position and yeah, it seems to be fixed now. Okay, so we have a nice solid image, right? But you can see that as I type characters, we're getting a bunch of gibberish and garbage. I think what's happening is, remember originally we had only 7 bits of video RAM, and when we looked at the character map on the Diagnostic ROM, there were 2 sets of all the uppercase letters. And I think what's happening is BASIC is using the wrong set. It's using the first set, but once I added that 8th bit of memory, that first set became the Greek characters, which is where the control characters are normally in the ASCII character set. Stuff that's written for all the later machines that support uppercase, lowercase, like the Model 3, are going to use the second set of letters. But I think this particular version of BASIC, which I can't really tell which one it is by looking at the screen here, I think this one's using the wrong set. So what's weird is all the articles that I read about this thing didn't mention this particular problem. So I think I need to try to replace these particular ROM chips, and I'm going to have to flash new ROM chips that are going to have a version of BASIC that are going to be compatible with the 8-bit video memory and the lower case. So I guess while we wait for this thing to fail here for this like video output problem, let me go grab the Data IO 2900 and let's make some ROM chips. All right, as you can probably notice by the change in the color of my shirt, it's actually been several days since I recorded the last part, but this machine has been working absolutely flawlessly. Since fixing that voltage regulator, that actually seemed to completely fix this machine. Clearly, those 74C chips used in the video output sync circuitry were being glitched, I guess, by the unstable voltage that was being created by the voltage regulator not working properly. There's also one other improvement since fixing the voltage regulator. Originally, the entire image was a little bit wavy, and I assumed it was the horizontal control pot that was just a little bit dirty or not working so well. I had mentioned replacing it with a resistor. Well, now that the regulator is fixed, the image is rock solid. No more issues whatsoever. So I think the last thing to do before I close this thing up is just fix these ROMs. So I found a great webpage on TRS-80.com that breaks down all the different versions of the ROMs for this machine, and we can kind of look at the differences here. So let's take a look at this page here. So level 1 ROMs, there are 2 ROM chips. Those are the original 2 that went on the motherboard. And clearly this one's got a level 3 ROM, or sorry, level 2 ROM expansion kit, which is what this little circuit board is here on the bottom of the keyboard. Version 1.0, 1.1 and 1.2 looks like, I guess, the only change between 1.1 and 1.2 was the ROM C, and then there's also a 1.3. Now, what's interesting, if we keep scrolling down, is it does talk about the actual differences in the ROMs. And I've read through all of this, and the weird thing is it does not mention anywhere in here that at least one version of these ROMs is actually using the wrong ASCII character set. But clearly, we can see that this version of the level 2 ROMs here, it's not working properly. There were several bug fixes, all sorts of different things between the different ROMs here. And looking at the changes from version 1.2 to 1.3, it says Radio Shack level 2 basic, and it goes to RSL2 basic. And it looks like one other change, which I think is going to be relevant here, is there's a new keyboard debounce routine in the version 1.3 ROM. And I've noticed on this keyboard, I mean, I tried typing a few basic programs just blindly because I can't read what's on the screen. It's just garbage, right? I noticed that some of the keys actually cause a little bit of bouncing. Now, this is a stack pull keyboard. It's notorious for that. I think I can like take the keycaps off and clean the contacts and stuff. But maybe the debounce routine will actually fix that problem as well. Okay, so clearly I need to make a set of ROMs. Now the question is, how do I do that? So these are the 3 ROM chips right here. These are mask ROMs. And what I don't know is, are these ROMs configured in a pinout for 2732s or TMS 2532s? I've found that most mask ROMs actually have the pinout of the 2532 EEPROMs. Here's the pinout for the 2732, and here's the pinout for the 2532. And right here you'll notice these are the differences. 21, 20, 19, and 18. We go back to the 2732, A11 is on pin 21, but on here that is VPP, which is just held at 5 volts when you're using the EEPROM without programming it. We also have pin 18 on the 2732, which is like the chip enable signal. And on the other one, that is on pin 20. It's the PD or power down signal, which actually like turns off the ROM basically. Similar functionality to that chip enable pin on the other one. Now, personally, I found that most of the time, these mask ROMs are always basically set up with the same pinout as the 2332s, which basically means that the 2532 EEPROM is usually compatible. Not always, but usually. Okay, so I've just pulled out this chip here. This is the chip that actually boots the system. This is the first of the 3 ROMs. I'm gonna put this into the EEPROM programmer and let's try to read this out as a 2532. And if we get a good read on it, then we know that the pinout of these is actually for 2532. Now for reading and trying to program a 2532, you cannot just use a normal Mini Pro. None of the Mini Pros that I'm aware of actually support the 2532 at all. I'm going to be using the GQ 4x4 programmer here, which is a little bit more expensive than the Mini Pro. But what's cool about this is it actually fully supports 2716s, 2516s, 2532s, and 2732s. It has an external power supply connection right here, which means this thing can properly supply the current and the 25 volt programming voltage that a lot of these older chips actually require. Okay, here's the programming software, and as you see there, it's configured for a TMS 2532. We are just going to try to read this chip, not program it, obviously. That would probably damage it. And let's hit read, and let's check out the buffer, and there it is. One thing that has me a little bit worried is obviously this read it out perfectly, but memory size Radio Shack level 2 basic right there is written in normal ASCII. That's not in that weird first character set that I said it was using that's showing up as Greek. So that means either my mod for the video memory isn't working properly, or I somehow did something wrong, or this early version of the basic ROM here, even though that's written in ASCII there, converts it down to work on a 7-bit machine. So I guess what we're gonna have to do is program some 2532s with a version 1.3 ROM and just hope that that fixes the problem. Now that brings me to 2532 chips. I bought these right here off of eBay, and that one doesn't have anything on it. And unfortunately, these are fakes. They're not fake in that these are not EEPROMs. These are EEPROMs, but they have been rebadged as TMS 2532s, and they are absolutely freaking not. This chip right here is an actual TMS 2532. You can see what's going on through the window there. It looks totally different. And this one here is much larger and yeah, not right. This actually shows up as a Hitachi, I don't know, HM, whatever. It's a 2732. So it's not 2516, and it is not compatible at all with the 2532s. So I kept these. I didn't send them back to the seller, but the thing is, it kind of annoyed me, but to be honest, they are all good 2732 chips. And at the time, I didn't have a lot of those, so I kept them. But buyer beware on eBay. I mean, I just don't get it. Now these TMS 2532s I also bought from eBay, and they also came from China, and they're legit. And they came in tubes, and I think I got 10 or 20 of them. And so far so good, they've all worked perfectly. And when I look at the die on a microscope, I can see these are made by Texas Instruments. All right, so let's pop this in here. This is gonna be the first chip. After a little bit of searching, I was able to find the version 1.3 Model 1 ROMs, and here they are. They're all 4K in size. Let's open up the first one, which I think is the Z33 here. All right, and there we go. So we can see mem size R/S. So that's the one we saw in the differences file. So let's program this. I think there's nothing much to do. I'll just blank check real quick here. Chip is blank, and we will hit program, which is right here, right. Okay, so that one programmed, that's the first chip. Let's open up Z34, and we'll blank check this chip. Chip is blank, let's write. Now, one little tidbit, if you don't have one of these programmers and you're trying to program 2532s, you really can't, but you can use 2732s in place of these with an adapter PCB, or potentially you can make an adapter with a couple sockets. You have to rearrange those wires. It's a little bit of a pain, and look at that, this one did not program correctly. All right, so I guess I have one dud. Let's do the next chip here. And this one's not working either. So that is really interesting because obviously I just programmed this one and it worked. So why is there a difference here? I don't know. And looking at these chips, like the one in my right hand is what I already programmed. They have identical markings on them. Pretty much the same on the bottom as well. Can't really explain what's going on here unless these two chips are bad. I'm gonna grab a couple more. All right, here is another one, fresh out of the package. Yeah, and this one's not programming either. So strange, so strange. I don't see how these can all be bad. That just doesn't seem possible to me. Okay, I just picked another one out of the package and it programmed properly. So that's weird. So much for getting good chips, I guess. So there we go, we have 1 and 2. Hopefully I have one more that works and I can get the third chip. Otherwise, I'm kind of stuck with this particular video. All right, loading up the third file, the ZL2 file. Let's just blank check this chip I just stuck in there. Yep, and let's hit right. So far, these 3 chips don't work, and I have one more that I haven't tried yet. Ooh, okay, this chip didn't work either, so now we're up to 4 chips that are bad. We're on the last chip here. Come on, no, it didn't work either. Okay, this sucks. It really sucks. Okay, so 5 chips that don't work. I think at this point, the only thing I can try doing is getting the data I/O, and I'll try programming with that. All right, I have the data I/O sitting here on the bench. It doesn't really fit in the camera view because the computer's in the way. So here's a picture of it. It's a big device. It's got a Motorola 68000 inside, and you communicate it via a serial port, and it has a floppy drive as well, which I have a GoTech in here, just so I don't have to worry about the floppy disk going bad. But that's how you would get files off and on this thing to burn or copy off EPROMs. Here's the interface here. Let's see here, we got to select a device. The interface is a little archaic, but I'm kind of used to it. So we're going to go to Texas Instruments, which is 43. And these chips here, they say 2532A on them. So that's what we're going to pick on the screen here, which is 27. We're going to hit enter. It's gonna look for the algorithm file. I gotta switch the disk. So let's try a blank check on this. I mean, it should already be blank. Execute, operation complete. I copied the ROMs onto the GoTech, onto a blank disk image on there, and there they are. We are looking for TRS-80 alt.zl2. That was the third ROM that I haven't yet programmed. So we're gonna load that into memory. I think we have to hit enter, loading data file. The disk operations on this thing are really slow, although that was quick because the file was so small. So now we go to program device, and let's see what happens. This particular one that's in here says bad with a question mark on it. So I'm wondering if I had actually had this problem already where it writes and comes back all FF. And look, operation failed, verify data. Let's just skip over this chip because I wrote bad on this and I don't remember what exactly is the bad. Let's grab one of the ones that we were just testing that weren't working. Okay, here we go. Let's try again. Program device. Oh, and right away it says device overcurrent fault. So I'm wondering if these are damaged. They got damaged previously. Let me just go through them all. Yeah, unfortunately, this typically happens if you put an EPROM in backwards, overcurrent fault. It kind of damages the chip inside. Yeah, that is that. We have 5 dead ones. I'm a little disheartened here. I've been looking everywhere in the basement and I cannot find any more TMS 2532s, even ones that have been programmed that I installed into things. Oh, well, the eraser is done here, it beeps. These are the trials and tribulations of working on old machines. You just never know what exactly is gonna go wrong. And I feel like I'm so close to the finish line with this machine. Like, the machine actually works. It just needs this ROM upgrade, I'm pretty sure. And yet, I don't have the chips. And all these bad chips. Like, give me a break. Ugh, so frustrating. All right, time for a little ingenuity. I'm going to try to figure out what to do. Alrighty, I am back. Some time has passed. I could not find another TMS 2532 anywhere in the basement. So I decided to start looking into what exactly I might have done wrong with my modification. So what I did is I grabbed my other TRS-80 Model 1, the one that's not working properly, and this is it right here. I have the Diagnostic ROM in there. It has a ROM board here that has just 2 ROM chips on it. So one's a 2364 and one's a 2332. Unfortunately, this machine is not working completely right, and that's really because this ribbon cable here that connects this ROM board to this side of the motherboard has gone bad. And I've tried to recrimp this to fix it, and it's just completely not reliable. Like, you can jiggle the wire and the computer crashes and stuff like that. So I think this machine would work fine if I replace that. This computer is the one that has been exposed to a lot of corrosion that I mentioned. The reason this machine is on the bench is I knew this thing had working lowercase in BASIC. And of course, BASIC didn't show those bad characters. So something's different about this machine than the other one. So I broke this out to take a look at what the difference is. The diagnostic ROM is in here, and it's running the diagnostic ROM right now. Now, right off the bat, you can notice that the at symbol through like the underscore is doubled up. Those Greek characters aren't on this character generator. It's this IC right here that's actually the character generator on this machine. And the fact is that this has the piggybacked video RAM chip here with a couple wires wired up to different places than the way I did it. But I don't think that's the reason why it's different. I think the character generator itself, oops, I just crashed the computer. I think the character generator itself is actually what's different between these two machines. And one way I can tell is looking at the lowercase characters. The G and the Y have descenders that actually go 1 pixel below the rest of the characters. On the other machine, that doesn't exist that way. The descender there is actually up at the same line as all the rest of the bottom pixel of all the other characters. And then, of course, the biggest difference right here is that those first 32 characters are those Greek symbols on my other one, and on this one, they're just the uppercase letters. So I'm thinking that this character ROM chip just has those characters doubled, and they did away with those Greek characters altogether. As a test, what I'm going to do is I'm going to remove the character generator from the other machine, and I will stick it in this one, and let's see exactly what happens with those first 32 characters. All right, here's the character generator. Turns out it was already in a socket. I guess they anticipated that someone might be doing these upgrades? I don't know. So this one has an 8 on it. That is, I wrote the number 8 on it. And this one here is from the other machine, and it's got a 7 on it. Let's install this. All right, there we go. What do we get? There it is. You can see the first 32 characters are Greek, and then the descender on the G and the P and the Q, the whole letter is shifted up. So that means that all the problems I was having with the Model 1 ROMs on the other machine were actually due to the character generator. And the funny thing is, I swear I read so many documents and no one mentioned this. They were like, just do the mod, it's really easy. Well, maybe these are early machines, maybe these are the early character generators, and maybe later machines had this later character generator. And part of the problem is, of course, this package is so little that, I mean, can you get these anymore? I guess I should try to figure out the part numbers and see if I can buy one, because I'm gonna steal the character generator that was from this less good machine, and I'm gonna put it into the other one. And then, of course, I'm just gonna restore the ROMs back to the way they were, because I can't find that extra ROM chip to make it work. This video, I gotta say, it's a frustrating one for me to make, and I'm sure it's a frustrating one for you to watch. When it comes to these machines, it's kind of frustrating because the thing is, the Model 3 ROMs, I don't know if they actually would work on these machines, but obviously the Model 3 basic ROM doesn't have this particular problem with the character generator where it's always using that first 32 set of characters. The Model 3, its uppercase characters are that, well, down on that second line there when you look at the screen here. So if I could just adapt the Model 3 ROMs to work on this thing, maybe that would solve all the issues. Well, I guess part of the problem is, though, the Model 3 has extra keys on the keyboard, and maybe that has something to do with the reason why it's got a different set of ROMs than the Model 1. Incidentally, if you are wondering, the screws on this one are silver or zinc coated or whatever, so they are not all corroded like they were on the other one. So even though this machine's been through the ringer when it comes to corrosion, the voltage regulator here never had a problem. This thing is running hot like it should. When it comes to the character generator ROMs, unfortunately, the one that is the 8-bit variant, it's impossible to read the markings. They're like mostly rubbed off. The 7-bit one is 8046670. That's a Radio Shack part number. There's nothing else written on it. The 8-bit one is 8046, and I just can't read the rest. And it looks like there's a Motorola part number on there, SCM37530P, but it's completely rubbed off. All right, this is the better motherboard. We're gonna reinstall the character generator in here. I'm gonna steal the one with the descenders and the one that's gonna actually work. I took it off the other board. You may notice that this has a keyboard cable here because I removed that thin ribbon cable. That was a pain to take off, but it was starting to corrode. So yeah, that's gone. I soldered on a set of PID headers there, just 20. This is a little short IDE cable here. And then I will do the same on the keyboard, and it just sort of loops around like this and then connects to the keyboard. And it's much easier. You can remove the keyboard at will. The only thing I had to do was this little board here, which I think is a Schmidt trigger for the cassette port. Someone said in the comments that was attached to the keyboard. I just relocated it up there so that the keyboard can come free anytime. All right, for now, I'm gonna remove these ROMs that I was trying to make. I do have the bad one in here. The computer seemed to boot okay with that in there, but clearly it's a problem. That ROM has issues, so anything that calls that ROM chip is gonna have problems. So this one with the X, this one goes into the dead parts bin. These two can be reused at a future time, and I'm gonna have to order some more TMS 2532s so I can make a complete set of those new, more modern ones with that keyboard bounce routine. Okay, I plugged the diagnostic ROM into this expansion board, which should work. Power connector is in, the video is connected, and let's turn this on. Oh yeah, there it is. It was the character generator the whole time. Now, the video is flickering on and off, and I'm telling you, that's the RetroTink, and it just is these little analog controls there. I just banged on them, and now it's stabilized. So now, let's put in some ROMs in here so I can get this thing fully assembled and actually working. Okay, so finally, the machine's working. It is actually working. So just to reiterate, if you do the video RAM upgrade for lowercase, you must, I repeat, you must also upgrade the character generator, or this machine will not work properly in BASIC. It's possible that booting into like TRS-DOS, things like that will work because that's the same software that runs on the Model 3, but absolutely the BASIC on this thing will not work. You'll get those bad characters. All right, I think at this point, I'm gonna put this computer back together. I'm gonna put the original ROMs back in here because I don't wanna run it with this bad ROM. And let's finally test that external monitor, and I'll get the expansion interface out and we'll boot into DOS. Okay, here is the monitor, the video display that goes with this computer. Let's power this up. There it is. Yeah, so that looks good. It's very clear, not wavy, no issues whatsoever. Pots are a little scratchy, but that's understandable, right? If you aren't familiar with this monitor, it's actually a television set made by RCA. In fact, like the channel selector would be there, and like this would be for the front speaker, and the cable that plugs into the computer actually comes out of the front where one of the knobs would have been. If you want to use a higher resolution monitor, all you have to do is you get a DIN5, and it's just a normal composite video output. So you can hook it up to any higher resolution monitor than this if you so desire. But at least this has the styling of the machine, the silver paint, the black here and here, and of course the TRS-80 video display badge right there. And the thing about the monitor is it sits very nicely on top of this, which is the TRS-80 expansion interface. Inside this box here is the additional 38K of RAM to bring this thing up to a total of 48, along with a bunch of expansion ports. This thing has seen better days. This did not come from Kevin. The corner's broken off. I think I have all of the covers, but inside of this thing, there's a power supply, which is why this cable is here. There's also a disk drive controller, which plugs into one of these edge connectors. This particular one has a serial port in it, it has a parallel port in it, and it also has a double-sided floppy drive controller, or rather double density. So you can store more data on the disks than you can with a single density, of course. I think double density allows for potentially 180K per side or 160K per side. It's got a couple less tracks, or 5 less tracks than a normal disk drive does. This cable right here is what plugs into the expansion connector on the computer. And yes, this ribbon cable here is carrying the data bus, the address bus, some signaling, stuff like that. So it's all a little bit janky. You just touch this thing and you can crash your computer and stuff like that. Radio Shack did not install buffers on the motherboard of this machine. They just drive from the CPU directly out that ribbon cable. I think there are buffers inside of this thing, but later versions of this cable actually have a little bit of active electronics with some buffer chips right here, and they're powered from, I guess, the computer, and that helps it push the signal across this particular ribbon cable. All right, the expansion interface sits nicely under the monitor. The monitor actually kind of slots in there to all the feet do, so it doesn't slide around on there. I have it connected to the TRS-80. Incidentally, you can take the power supply for the computer and put it inside of the expansion interfacer's space inside there to hold both of the power bricks. Although these get pretty warm, and I'm assuming inside of here it's probably going to get pretty toasty. In fact, this is kind of making an annoying buzzing sound. There we go, it's quiet now. Okay, so let's turn all this on. Monitor on first, then we got to turn on the expansion interface, like that, and then we turn on the computer. Now, this is normal. It goes to this screen here because it is trying to boot the floppy drive. So what we need to do is hold down the brake key while we turn on the computer, and there we go. Now it goes to memory size. Now we should have access to all 48K of memory. And actually, why don't we test that out with the diagnostic ROM? ROM A is out, and this is the diagnostic ROM, and I added an extra socket just for clearance purposes. And let's plug the expansion interface back in here. Let's turn it on. Let's turn on the computer. All right, here we go. It's running the diagnostic. Turn off the light there so it's a little clearer. I've actually never tested all the memory inside the expansion interface. I've had this expansion interface for a number of years. All right, so first and second bank test good. So that second one is inside the expansion interface, and so is the third. So all 3 banks are working, which is internal to the computer, and 2 in the expansion interface. That is cool. Let's see what happens if I turn off the expansion interface while it's running the diagnostic. Oh, right away, it crashed the whole computer. Hey, at least it recovered, right? All right, let's try booting some software. I have a floppy drive here. It's in an old CD-ROM case of some kind. I just ran the floppy cable out the back like this, and it's got both 34-pin connector and an edge connector, perfect for using on machines like this. This should be set for drive select 0, which is perfect for this, and it has an internal power supply. All right, we have the floppy drive connected. It plugs in the back. I'll just turn that on. There it is. Expansion interface on, and let's turn on the computer. There it goes, starting to load, and no system. Okay, that's interesting. This should be a boot disk. It does say TRS-80 Model 1. Let me grab a different one. All of my Model 1 disks seem to boot to this no sys message. But to be honest, I haven't used the disk drive controller in this in a long time, and I don't really remember if any of these are boot disks. They don't say they are. Let me go make a new disk. Okay, we have another disk here. It's unlabeled, but this should be new DOS 80. I made this on IMD on my PC. I have a video I will link to in the description below about making disks for the TRS-80 Model 1. Look at that, that is working. So obviously, this pile of floppies I have here filled with games and stuff, none of these are actually boot disks. And DIR, I think, is the way you look at the directory. Let's try running the disassembler here. Object from memory or disk, let's say memory. And base address, I don't know, let's do 0100. Virtual base address, real base address, I don't know, 100. Any options? No. Bad reply. Okay, all right, there it is. It's disassembling memory. I don't even know what's in that part of memory, but there it is. Cool. Oh yeah, this is part of the ROM. ROM starts at 0000. Ideally, you should have 2 disk drives so that you can run some of these programs here. Why don't we try Games 3? Hopefully it can handle swapping disks around and doesn't require the operating system disk to be in there, even to do simple stuff like dir. Seems to be reading the directory. No sys. Okay, that was not the case. And with that, I think I've reached the end of the Model 1 series, at least for now. This computer was in really nice shape when Kevin gave it to me, and I really didn't think anything was going to be wrong with it. And to be honest, very little was wrong with it. The only actual problem was the screw on the voltage regulator, and that was it. That was just causing those glitches on the video circuitry. I think I caused myself a bunch of pain and grief by doing that 8-bit video RAM upgrade on it. Was it really even necessary? I'm not sure, but I know that was a pretty common mod to do back in the day, and the only thing that really threw me for a loop is not realizing that it was the character generator that also needed to be upgraded. I remember reading somewhere on the internet recently that that was something that needed to be done or was common to be done at the same time, but like I had mentioned in the video earlier, most of the upgrade documentation I saw didn't really specify that BASIC would not work at all unless you disabled the 7-bit upgrade or, of course, upgraded your character ROM. And it was confusing to me because, of course, I knew that my other TRS-80, the one that I ended up stealing a chip from, worked all the time in BASIC with the lowercase mod, so why wasn't this one working? Well, there you go. When it comes to the TRS-80 itself, you could probably tell that I was getting a little bit frustrated with this machine, not this specific machine, but just the TRS-80 in general, the very first one here. It felt like Radio Shack was definitely cutting a lot of corners to get this thing to a price point, and compared to the Commodore PET 2001-8 and the Apple II, it just felt like so much more cost cutting was going on with this machine that clearly I don't think the engineers necessarily wanted it, but Radio Shack probably forced their hand. Like the fact that all of the circuitry to decode all 8 bits of video RAM is there, but then they didn't include that extra chip, they didn't even leave a socket for it, it just feels like that was penny pinching on Radio Shack's part. Even with all my frustration, I'm very thankful to actually have the TRS-80 Model 1 just because of the historical context. And of course, thank you very much, Kevin, again, for bringing me this minty fresh example where even those little spacers are supple. And yeah, nicer monitor as well. Now, speaking of the origin of this particular computer and monitor, these belong to the family of Al Miner, and actually specifically his grandfather and his uncle, who used this TRS-80 and a whole bunch of other TRS-80 and Tandy machines to run the family business for a long time. Al told me in an email that his grandfather was a Radio Shack super fan, so that's why he kind of had like every Tandy and TRS-80 machine there was under the sun, and he kept them all in absolutely perfect condition over the years as he upgraded to the newer models to, you know, make his business run more efficiently or whatnot. But so cool to know a little bit of the history of this, and yeah, this was bought in Kansas at Radio Shack in what, like 1978 or something like that, as we saw from those stickers, which is just absolutely awesome. All right, I think that is going to be it for this Model 1 on the channel, at least for now, unless it decides to just break before I put it away again, which honestly feels like that might be possible. I will be trying to revisit this other Model 1 soon to try to get this thing working properly again, make it a little bit more stable. When I got this thing, it had so much corrosion on it that the ribbon cable, like I said, is very flaky, but all of these bodge wires as well had come loose. I had to resolder all of them. And while I'm pretty sure I got them in the right place, maybe there's bad connections there as well, and it causes instability. In fact, the 8-bit RAM upgrade that was done on this thing, when I was switching out the character generator, I touched one of the wires and like it just fell right off. It literally fell off. So this whole thing is, well, it's seen better days. So if you liked watching me struggle with this TRS-80 Model 1, I'd appreciate a thumbs up. If you didn't, you know what to do. Thanks to my patrons, their names are scrolling beside the screen. They get early access to videos and other behind the scenes goodies. Thanks to Kevin for bringing the machine to me. Thanks to Al for giving it to Kevin in the first place. And thanks to Al's grandpa for keeping all of this stuff in such perfect condition over the years. And thanks to Radio Shack for actually making this thing in 1977 and putting me through a whole bunch of torture almost 45 years later. So that is gonna be that. So stay healthy, stay safe, and I will see you next time. Bye.